You've only got one unknown, and that is x, and you can know that x should probably be a negative number because you know the answer has got to have a sense going in the negative x direction. I will not solve it farther than this right now. I want you to do the same. And I want you to first solve it by logic. Force times distance equals force times distance. You notice we're not solving for the reactions up here. We should do that in the end as a check, but for now we're just trying to get the point of you take your hydrostatic force, which in the end was 3120, at 2/3 of the distance of 10, balanced with a force that's farther away, so it has to be less. You'll know the answer. Now I want you to write out these two and realize that this is the definition of the moment of a hydrostatic force, defined by the radial vector, which is a minus in the z direction, the way we've defined it. The force is a positive in the x direction. You can get the determinant of this, which is the moment. You can also do the same here, I, j, k, 0, 0, minus 10 now instead of minus 20/3. And then x being the unknown, because we know that this has only an x component. You solve for x, and the x will be a negative number. It should be equal to that ratio, the lesser ratio, so it's going to be 20/3 divided by 10 times 3120 will be the answer you get. This is a lot of overkill, I would say, for this problem, which is a basic problem of force times distance. However, once you start getting used to putting it in the standard engineering notation and also looking at the moment as two ways, this way being the radial vector magnitude times the force vector magnitude times the sine of the angle between them, the sine of the angle between them being the theta in the force, or the direction of the force, minus the direction of the radial vector, you will be so far ahead of how to do this stuff in a spreadsheet, in CAD, by hand, with logic, not only in 2 dimensions, but in 3 dimensions as well. Try to figure out the solution. Try to follow it. If you do not follow it, go out and look a little bit about vector notation for moment out in Wikipedia. Thanks for listening.